Randall, our first speaker of the day. Randall is no stranger to the GigCityElixir stage, a returning champion of the conference. Randall is a classically trained musician that took one too many calculus classes and got sucked into geekery. That's right. Computers, robots, video games, high-energy physics, all the usual suspects. He's afflicted with rabid technology ADD. Randall's built companies in various industries with numerous startups, everything from robotics to digital video to cloud computing. After escaping a high-security military prison and driving heavily armed conversion van filled with ex-spec ops soldiers for hire around Los Angeles underground.
Hold on, stop. Not a single 18 fan? Really?
Wow. Come on. It's a good call out. We want to keep the call out culture alive, that's for sure. Randall founded Thunderbolt Labs, a software consultancy that teaches companies how to build better software by embedding with their teams and building it beside them. Randall's an internationally recognized speaker on practical data techniques and the insanely nonsensical business of startups. Randall is likely lost in a book or on a running trail when not glued to a computer, wondering if he will get to the end of either. He has a fondness for good food and a weakness for great whiskey, and will happily discuss either at length. I asked Randall, I said, what's your greatest technological regret? And his answer was that Laserdisc didn't win. Everybody give it up for Randall Thomas.
Checking, okay. So, thank you. Oh, and by the way, it was the Star Wars special edition on Laserdisc. Does anybody remember when those came out, 12-inch Laserdisc? Thank you. Yes, thank you. And I think they were about 100 or 150 bucks a disc, and it was, the worst part is about 54 minutes in, you had to basically get up, flip the disc over, right? And don't worry, my other choice was Betamax. So I had to revise upwards to fail. Anyway, so, oh, mini disc, yeah. I learned my lesson after that. So this is this usually, at this point, I would talk about Thunderbolt Labs, but you already heard that. That's what I get for actually not deleting everything on LinkedIn. The only part of that was true is I did drive a conversion van. I mean, at least I always wanted to. I also would like to basically put the nutritional content warning for my talk here, because has anybody ever seen me present at Gig City? You'll know that I'm a big fan of FTP, which is not the ancient but still used file transfer protocol. I am a freelance technical pessimist, right? So in other words, I'm the guy that when Node came out, I was talking to Rye going, this shit's not gonna work. And I think we can all say, well, we all have our regrets. Okay, so in about 10 years, somebody's gonna be coming up here, and instead of Laserdisc, they're gonna be in like React 16. That's what they're gonna say. Be that as it may. Last time on GigCityElixir, ding ding, you might have recognized this talk and Bruce's favorite slide. And I did promise Bruce that I would not open with yet another mushroom cloud. I did not say I did not have a mushroom cloud. So unless you saw this talk, you might not understand that I'm the guy who gives you such hits as, if our extinction, oh really, it went to sleep? Oh, come on. Here we go. So I'll have to actually keep tapping that for a little bit. So if our extinction proceeds slowly enough to allow a moment of horrified realization, the doers of the deed will likely be quite taken aback, realizing that they have actually destroyed the world. And other 8 a.m. hits like this. These are the things which will make sure you have a very nice day, and that's why I'm opening your conference. So, where are we going with this today? We're gonna talk about some patterns of compute. This is my new lighter weight upbeat version. We're gonna talk a little about languages and application of languages. I have one slide on AI because it's obligatory. If you don't have AI, you're not relevant anymore. And we're gonna try and bring it all together into some sort of nice end. So first, we're going to open up with talking about constraint-based programming. Has anybody ever heard of constraint-based programming? Everybody's hand should be up, because the people who just raised their hand, they think that I'm talking about the mathematical version that smart people do. I'm actually talking about why you guys are employed. So let's take this back to the abacus. A long time ago, if you wanted to calculate something, this is what you would use, an abacus, right? And if you were the abacus guy, you were the most important man in whatever counting house, tally house, Medici house that you had, right? But realistically, because engineers ultimately reduce everything to a series of box and arrows, this is the model, right? So abacus guy got paid for doing this. How do you scale out abacus guy? You get a lot of them. So you put together a counting house. You basically more or less create Ernst & Young, right? And if you remember when Ernst & Young got into technology, it did not end well for anybody except maybe Enron. But I digress. So realistically, a counting room has a model that kind of looks like this, right? You just keep adding people. It's a meat cloud. It's the first effective thing. And in fact, I think this is also an architecture diagram for Amazon's checkout shopping thing, but I'm not real sure. So the funny thing about this is that ultimately this is a von Neumann architecture, right? If you leave the central processing unit and everything else, you basically have an input, you have something that has some memory, it does some sort of operation, and then it's the output device. The abacus, ironically, and this is the funny part, is the memory in that, that architecture, right? The person is just the CPU, right? Which means that ultimately we can reduce that architecture down to this, right? Which leads us to the von Neumann bottleneck. I think it's actually for the fancy people that are basically saying it's von Neumann, but this is what we all done. How many people have, actually, okay, we're gonna go gray beard check here. How many people here remember, I'm just gonna call it an architecture, 386s? Oh, wow, sorry, Bruce, I'm trying to remember not to curse like a sailor. Yeah, 386s. So do you remember like the 386? Does anybody remember the 386 and the 386 sucks? Here, right? Exactly, the one without the math coprocessor. Do you remember Celerons? Celeron 300As, Pentium 2s, Pentium 3s. You remember how we just started getting faster and faster chips and putting more and more cache in them? Does anybody remember all the other things that happened, like rowhammer, cache poisoning attacks, right? This was all to get around the von Neumann bottleneck, which is the problem with this model is that ultimately there's not a lot of ways to scale it out. You can't do a lot of scaling with it because they're all reading from the same memory bus. So we try little tricks like putting the memory on the CPU and then basically using the CPU still talking to the same memory. But really, at scale out's the same. And this is basically a multi-core architecture, right? So what you realize is that anytime you're working with von Neumann architecture, right, it's all about the caching strategy. And if you also remember, the person was the CPU in the abacus, which means that cache does rule everything around you, and anybody who's had to Google something that they should know off the top of their head, this is what we mean, right? So eventually we tried to scale this out by doing multiprocessors, and we started doing these like high-performance compute fabrics and all this other stuff. And did anybody actually buy microchannel? Does anybody remember this? Microchannel architecture? Yeah, okay. It's where the clicky-clacky keyboards. All you mechanical keyboard fans, you actually owe your keyboard to microarchitecture or microbus, because the only thing that actually kept after IBM launched that were the keyboards, right? But the point is, this is what like all these big fancy like HPCs, and when you want to like model an atomic explosion, like you might have seen on one of the slides earlier, this is what you would use, right? But eventually you run out of space there, and then so what do? How do you scale it up next? You put a bunch of them in the same place, right? So now we build data centers. So this is an architectural diagram of a data center. I think I've seen this before. Maybe, where have I seen this? Yeah, anyway. So what happens when you run out of space to put your data centers? So the cloud architecture, I'm going to tell you, gets really advanced. It's really, right? So cloud architectures are one of the greatest innovations known to man because they fix all the problems that we have with that pesky old von Neumann architecture, right? So why is this? I'm pretty sure we all understand that Moore's law that says programmer salaries double every 2 years given the change in JavaScript frameworks and technologies, right? So what's funny about this is if you look at it, literally the total density and the actual processing power, depending on who you want to go with and how you measure it, teraflops, blah, 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 is about 1 trillion times what it once was, right? And this data could be completely fictitious and made up because I asked ChatGPT, but some of it checks, right? And the thing that's really important is, aside from looking at the scaling on the left-hand side where you have 1 to the 12 and 1 to the minus 6, right, is just that the speed keeps going up and the price keeps going down. And that's actually in inflation-adjusted dollars for 2020. So, like one of the Summit computes, it's basically 0.001 cent per teraflop, whereas the ENIAC comes out to 13 million bucks, give or take, right? And fun fact, nobody actually, you can't really get true like comparison to apples comparisons, but that's kind of where an Apple Watch sits, right? So technically, you're wearing an SGI on your wrist. So what's the point of this? Well, okay, I'll tell you. How many people here have, gray beards? How many people have done a programming interview with somebody who's like just out of college? And I'm not picking on people just out of college, right? Okay, and how many of them have ever asked them a standard thing where it's like, you know, the old memory allocation, allocate me a linked list? Okay, who here in their first programming class actually didn't allocate memory? Who got out of college without allocating memory? Lots of people do. It's okay, right? There's no shame in it. But part of it is like, it used to be that these machines were very constrained, and now, realistically, I mean, who cares? This is the exact point of a React Native app, right? It's 500 megs, who cares? Download it. It's like, JSON? Sure. So let me get this straight. You have an integer encoded in a JSON struct? Yeah. Okay. So point is, everything is effectively unlimited. And we could go through the same argument and do it for pretty much everything from bandwidth, right? Storage. Does anybody here remember paying thousands of dollars for an SSD? I do. One of my first SSDs was $2,000, and it was the 512 megabyte Samsung, right? And a year later, I couldn't sell that Mac for like half of what I paid for it. So what it tells us is, likely it or not, I posit that cheap ubiquitous computing is pretty much a given. If those curves keep going this way, eventually you'll be able to spin up your own supercomputer, do your own protein folding at home, maybe start your own SETI project, right? So we're gonna skip over. There was a time called the dark age of technologies where if you wanted to program a computer, you actually needed wires, right? Does anybody know where debugging came from? Shout it out if you do. So pick somebody, anyone. That's all correct answers. Yes, because bugs would crawl into the actual physical relays in the vacuum tubes, right? So yeah, this basically is how you used to program a computer. So the model for working with computers was a person would program with wires. Don't worry, these architectural models are going to get very complex here in a second. So we started doing things like, well, this sucks. So we started inventing tools, and the tools were there to otherwise assist that programming. And once we went away from mechanical, electromechanical computers to digital computers, we started writing things in machine code. And did anybody ever have like a DOS machine and command.com and like go in and byte edit your command.com or patch your stuff? Yeah, okay, so this is what we used to do. Like, it used to be that we would actually write in either machine code or assembler. Like, we would actually go through on a piece of paper and assemble the opcodes and stick them in hex. But that sucks too, is you're prone to errors. So we started creating all these other things. BASIC, which is still around, still one of the most popular languages in existence. You know, COBOL, which also still around. And I'm sure there's another Y232K coming or something like that if you want a good job. BCPL, and one of my personal favorites, Logo, Turtles for the win, right? But if you think about it, the model for almost all of those languages was a person put stuff into a text file. And forgive me, I'm a graybeard. I started off on an Atari 800. We actually used to have to type the entire program in, and it could take you 3 hours. And the best part is, if you turn off your computer, do you know what happens to your program? That's right, gone. So, 70s and 80s, people said, well, that sucks again. We need more structure to these programs, because when we program BASIC, you might have seen GoTo considered harmful. Remember the joke? There was actually an article about whether or not spaghetti code writing GoTo and unconditional jumps was a good idea. So they started creating all these tools like, we've all heard of C, yes. Some of us have actually heard of Pascal. And yes, I know for all the other people who are being strict in here, Prolog is not a technically not a structured language. It's basically backwards chaining inference, but you could say that's a type of structure. But I just stuck it in there because I think it's an interesting thing that Prolog is really old and it's now coming back again. And if you ever, I'm gonna pick on Quinn, if you ever wanna get a really good download on data log and inference and forward and backward chaining systems, you should talk to Quinn. But all these languages are here because we realized that it sucked to type into the same thing, dump it into memory, and you basically going back dead serious in a basic program. If you might have seen them with line numbers, 10, 20, 30. Does anybody know why you used to do that? None of the old people can answer. Yeah, exactly, if you know the answer. So for you youngins, we did that because if I numbered them from 10 to 20, that meant I could put exactly 10 more lines in between. So if I needed to go back and edit the program, I had two choices, and Vim didn't exist, at least not on home PCs. You actually had to go through and change all the line numbers, or you could just basically insert new instructions in between, because that was literally the memory layout, right? So this actually sort of took care of a lot of that stuff. But the structural model for this is actually still a little, right? Has anybody, and I know it was because a bunch of you were at NervesConf, so you guys can't answer because I know you guys have dealt with this. Anybody who doesn't deal with hardware, has anybody used a make file recently? Has anybody basically tried to like beat themselves to death with their keyboard after a make file or compile error? Or when Homebrew says something like, sorry, you have the wrong version of Yak, right? The interface isn't great. So in the 80s, we got smart. At least 1 out of 4 ain't bad. So what's interesting about this is that in the 80s, we started to have computers that had enough space, memory, time, and other things that we can start getting custom DSLs, right? In a lot of ways, Erlang was designed for telephony and telephony switches in those constrained environments. MATLAB was a DSL for just doing math, right? Before that, if you wanted to do math, your choices were pretty much Fortran or Fortran, right? Even C, you didn't write the math. You wrote it in Fortran and linked it to your C code. And then we actually had this terrible idea that was called C++, which seemed like a good idea at the time. I might put that one up there with also next to 12-inch laser discs. So the interface advanced as well, right? So the interface was super advanced. Anybody remember paying $5,000 for Microsoft Visual Studio? $6,000 for Borland C++? No? So back in the old days, kids, we actually had to license our IDEs. They were fairly expensive. Some of them came with dongles, so you couldn't even move it from the computer you installed it on, right? So, but the interface is still this, right? Until the 90s, right? Yeah. Nirvana is in, Soundgarden's touring, Pearl Jam was actually still making eye contact with their fans. Right, so, and JavaScript's there for a reason. Douglas Crockford, bless his heart, he wrote a JavaScript, The Good Parts, which you should go read at some point in time. But you start to notice that there's something very different about these languages. Visual Basic gave rise to the Office application. It's probably, I would argue, the first real language that non-programmers used. There was no hardware expertise. There was no esoteric expertise. It was actually designed for for user comfort for a change, which nothing else at this point really was, right? JavaScript was a domain-specific language for working in a specific target environment. Ruby took a different approach. Python, and we can talk about Haskell offline. It's still a thing. There's a lot of sore points there. But it was around in the 90s, right? And all of those things had great user interfaces. Yeah, there's nothing better than opening up a sentence, right-clicking on it, and then going and editing the code behind your underlined word. Yes, that's right. You could used to be able to write Visual Basic macros in Microsoft Word, which was actually still just attaching a separate text file to another text file, which was your Word doc, right? Until the modern era, which strangely enough is still going on, a lot of the tools and things that we actually use for the past 20 years, right? Notice I actually inserted my own diversity clue into Friends. You don't want to see the original one the AI gave me. But something interesting in doing this talk, I actually found out. Anybody hear about Carbon? I hadn't heard of it really. No, Carbon is actually a new version of C++. It's meant to be backwards compatible with C++, being done by Google with a launch date in I think 2025 or 2026, and it's meant to be like C99 is to C, Carbon is to C++. 20, TR1, 18, 23, 14, 11, extension. Anyway, it doesn't matter. But notice here all of a sudden I would argue this is the age of nobody compiles anything anymore. You actually don't write anything. It's like I always argue nobody actually writes JavaScript. You write ES6 with a bunch of extensions. The same way nobody writes Haskell, right? You write a prelude and then you write something that goes with it. And the same thing with all these other languages. We have runtimes and libraries that we bring in and change the environment to actually make it easier to use. So for the first time, we're thinking about things like developer happiness, right? Matt says nice, so we are nice. Do you think anybody was running around to Alan Kay saying, Alan Kay is nice, so we are nice? It's like, just get it to compile, right? So it's a very different environment, but we did make grand steps in the user interface and the otherwise the structural diagram to how we interact with these things. Right? Does anybody remember life before GitHub? See? Don't swear at me, sir. So yes, there was life before GitHub, but it was painful. And strangely enough, professional programmers oftentimes didn't use version control because version control was the thing that would destroy your code. Version control was so unreliable, if it was really important, you kept a copy. You did not check it in, right? So, but this was the interface diagram, right? So, what do all of these things have in common? It's possibly one of these things. Visual Studio Code Kit had all of them. There's a JetBrains IDE you could pay for, an EVM plugin, and an Emacs mode that doesn't quite work. And I say that as an Emacs user, and it's getting harder and harder these days. But no, they're unchanged, right? Which is fascinating if you think about it. What we're saying is that for approximately 40-ish years, we have been unable to come up with a better way to do our daily work and articulate everything, these complex ideas, these abstractions of our lives, other than typing into a text buffer, right? And then saving it to a disk. And more importantly, then having flame wars over whose text buffer is better. Right? Do you have a modal text buffer or not? Right? So it's funny to me that this sort of indicates two possibilities. Clearly there's a continuum of them, but I want to posit these two things. Either A, we have actually reached the level of irreducible complexity in trying to build software and edit these types of programs, or we've really screwed something up because we've done nothing to improve our own lot for 40 years. Both things may be true, right? So when we think about this, the models in and of themselves are relatively the same. We've got two irreducible blocks. We've got external cache. We are the von Neumann machine typing away. We basically are the army of 1,000,000 monkeys. So who cares, right? Well, Told you I had my one slide on AI. Who here has not heard about the AI revolution? Well, I'm glad you asked. AI. It's kind of like a town without a monorail. Realistically, AI is the thing that's going to transform everything, take away your jobs. GitHub Copilot's coming for your job. It's also putting in 29% more bugs and 30% of the MITRE attack vulnerabilities every single time it runs. Right? So soon we will all be out of jobs. Exactly. Where do I join? So, but it will also democratize the very tools of those von Neumann architectures that you guys have slaved over to learn, internalize, and understand. It will basically divorce you from the text buffer. No constraints. This changes everything. So they say. It certainly has given some companies some absurd valuations, and has certainly given some people some ideas that they can go off and build, I don't know, AI chip fabs. So I want to make sure that we understand what we've done. So first we established that the new future is going to be essentially infinite resources, infinite computing power, infinite storage, on demand when you want it. Yes? And the second thing we said is that we are now allowing and removing all the constraints that you actually have to go, because frankly, learning an editor and learning the terminal is probably one of the hardest parts of becoming a developer. Compared to like reading a book on syntax, trying to remember how to actually do all these things, we are going to remove that. We are going to democratize this, and we are going to allow anybody, anywhere, to the power to program, control, and build an infinite pool of resources for any purpose that they like. Okay, let's look at it this way. We can help Truth Social scale. So tell them what they won, Bob. Well, this is actually the amount of water that one of Google's data centers consumes in one day in gallons. This is actually the amount of water they have reported that they have consumed for all of their data centers last year, with a goal to, I think, be net zero water by 2036. Now, I don't know about entropy, evaporation, and other things, but I'm pretty sure that won't work, but what do I know? I just tried to study physics. But power to the people, of course. This is the IEA estimate of the global power in terawatts consumed by all the data centers, 23 to 28% of which are located right here in the good old US of A. Right? By the way, it's expected to grow by almost 20% year over year, compound annual growth, over the next 6 to 7 years because of the AI revolution. This is the actual annual power consumption of California, the 5th largest economy in the world. This is the amount of money Microsoft and OpenAI are building to build a massive new data center called Stargate or something like that, which is going to have one of the highest densities of AI processors, storage, and memory in the world. And this is just something that came through my news feed last night, so I actually stuck it in. I'll wait for the laughter. So I'm going to point out two things. One fairly serious, which is the National Center for Missing and Exploited Children, which is one of the organizational clearinghouses for CSAM, is terrified by this because signal-to-noise ratio, they do have no tools that can actually differentiate realistic child porn generated by a computer versus realistic children that are actually been exploited. And there are currently groups right now that are mixing the two together to hide truly exploited children in with fakes. So it's a real kid, fake body, fake location, fake everything else. And on the lighter side, I don't know about you guys, but there's a song, I think, from Avenue Q called "The Internet's Made for Porn." Well, I don't know what this power utilization is going to be, but let's see, this is California. I'm pretty sure that Utah, Idaho, and everything else, once the AI porn is there, are gonna hit this power utilization real quick. So, kill -9, right? One of my favorite commands, fixes everything. When you absolutely positively have to kill every process in the room, and as a man once said. $1 billion, this is the estimated cost to print. Does anybody want to guess to print something? We have printers that print everything these days. Metal printers, we have circuit printers. Anyone? Anyone? Oh, that would be great. That actually, yeah, that's a good guess. The $1 billion to print the tax code? Yes. Because it's probably about 22 cents to the National Printing Office, and the rest of it is for an accountant and an accounting firm to explain it to you. Be that as it may, this is actually the cost in 2002 to print a complex virus like smallpox. So I don't know if you guys know, bioreactors and bioprinters are a thing. That's actually not to also pick on, but there are plenty of great hacks by some people here. You can talk about this, about biohacking. But the point is, you can print proteins. Anybody want to guess what this is? Correct. And the estimate is, this is when you have advanced knowledge of how to do the process. And this guy is the president of the Rand Corporation. He has this to say. More or less, they're pretty sure that AI and advanced AI, and they've tested this, is going to drive the cost of printing something like smallpox to close enough to zero that it won't matter. Remember those two lines? Right? The Rand Corporation is a think tank that's sort of government adjacent. They do lots of good work in policy. But the point is, we understand that everything that we're doing from these models actually might have some unintended and unexpected consequences, even from something simple as 2 joined boxes. Not calling any judgment, but this is a thing that's going on. Anybody who follows the war in Ukraine also understands that right now, Ukraine, more or less, is an experiment, is an incubator. It's like the Y Combinator of what the next generation of warfare is going to look like. Right? And I don't know about you. Does anybody actually, how many people here use dialyzer in their code? Oh, that's a lot more than I thought, because it used to be you'd hand up your dialyzer and people are like, don't put types in it, right? How many people after a while, when Credo and dialyzer tell you something, you just stop reading the code and you just do what it tells you? I do. Right? Like Credo, well, I guess I should move that. I don't know. It's an atom, but maybe I should take it out. I don't know. Well, I don't know. I guess it's a target, but I don't know. It looks like a kid. I don't know. I mean, it says it's a target. Too soon? 3 to 10%. This is the estimate of the total number of hallucinations that are going on in the currently deployed, largely in use LLMs. That means a hallucination is something you just got wrong. And here's the best part. I often wonder about that, which is, how do you know it's just not hiding the other ones? You know, imagine there's that Tinder date, you swiped right, you're like, hey, you're going out, and then like 2 hours in, you're like, are they just hiding the crazy? So that's what we know of. One of my favorite things is, I don't know if anybody knows who Robert Hare is, but Robert Hare is known for doing the Hare psychopathy inventory. It's the only tool that we have for trying to test out if somebody's actually a psychopath. And he's famous for sort of summarizing one of the things, which is, oh, just remember, the only people we've ever been able to study are the unsuccessful ones. So I might not have a psychopath test, I might have an unsuccessful psychopath test. Just putting that out there. Don't forget to vote. So, AI considered self-harmful. So I just want to put just a little bit of a warning, because I want to talk about, this is true and this has been seen. Sensitivity, we're going to talk a little bit about self-harm. AI is, because people have been engaged in parasocial relationships with their AI, they've bonded with these AIs, they talk to them like confidants, they're real people to them. And in this one instance, a woman did blame an AI for ultimately causing her husband to fall into a state of despair so much that he took his own life. And there have been other reports of people having these types of interactions. There was a company that turned off the sexy time chat and the ability to be more personal with one of their bots, where people had been programming against their API and making these bots. And so all of a sudden, these people described it like having a loss. Like a friend or a family member has all of a sudden iced you out or has died. They went through the same stages of grief as a person, losing a real person. And remember, we're going to make sure people can build as big an AI bot as they want. Right? Most of my great pessimistic quotes that sound like I'm just doing anything like intelligent with it instead of just being like it all sucks come from this gentleman right here. Machine Research Intelligence Institute, some great stuff, controversial, but worth a read to basically see what's on the other side. And one of the things that I want to point out is all those boxes I gave you earlier were a trick. They're reductionist. They're simplification. As somebody once said, it's only a model. Said that about Camelot, but we could say that about this too, right? Because it gives us a sense of understanding of what's going on. Like an ID gives us a sense of control, like I know where all the files are. When I love compiling Node apps because the thing I like about it at the end is 15,462 files compiled, 67 minor security vulnerabilities, and 12 things that are broken, right? So we think we understand these things because our mind reduces everything down to a series of boxes that we think we understand the connections of. And more importantly, we think we understand the second order effects of. So as I warned you, I am a pessimist, right? So here's the bait and switch. Is there a light at the end of the tunnel? Always remember, yes, there is, but always remember to ask the question, is that light attached to a train? Has anybody ever heard of the free lunch theorem? Correct. It's a trick question. There is, of course, there's no free lunch. The free lunch theorem doesn't exist, and neither does a free lunch. Really, that's the one that gets the There's been so many other terrible jokes. Like, oh, fine. Critic. So the point to remember here is that, funnily enough, through all of those languages and all of those parts of a von Neumann architecture, even though they're the same thing, what you figure out is that the abstractions we use on a daily basis to do our jobs and get paid for are not free. Someplace, somewhere, somebody is paying for it. Do you remember when somebody deleted left pad and broke the internet for a couple days? That was how you find out who's paying for something. Right? Right now, people in Arizona are paying for Facebook to basically scream out and create the best posts ever to teens who actually want to have body image issues, right? So all the abstractions, everything we do, our jobs are predicated upon abstractions that are paid somewhere. And the question is, are we aware of where that abstraction and by whom that abstraction is being paid for, or is it just one of those things where it's two boxes, I don't need to be worried about it? So my point here is that we spend so much time trying to remove the constraints from our environment. I would like to make sure that we take time to also think about the constraints in our environment that have a purpose other than just frustrating us. I mean, frankly, I can't count the number of times that I tried to remember how to do something in Emacs, and by the time I realized what the key macro and the entire chord was, I realized that it was the wrong thing to do anyway, and I just stopped. Oh, I don't need to increment that. It's actually just on the wrong side. Huh, funny, right? Constraints aren't necessarily your enemy. And I think it's funny because we spend so much time working around the constraints of our environment, we sometimes don't think about the constraints we can and maybe should be putting into the systems that we build. And if you're interested in other people who have thought about this significantly, there have been a lot of people who have done work in environmental sciences and systems thinking about looking at complex systems and trying to figure out the first, second order, and follow-on effects of those systems. In other words, the constraints that make that system thrive, the constraints that make that system die, and the constraints that make that system stay in balance. So What does it mean for us as like practitioners of technology? Frankly, I think one of the amazing things about Elixir is that Elixir actually has and has actively curated the constraints that we actually have for the language. So has Elixir. Erlang and the Beam. And it makes it a very powerful and great language to use, but you know, as I think somebody once said, with great power comes great responsibility. It wouldn't be a me talk unless I sent you to the library. Probably one of the first books that always comes up in any systems reading list will be this one. It's about thinking in systems. She actually specifically worked in environmental policy, but thought about actually how these complex interactions and complex ecosystems either collapse, fall, or live, especially predicated upon external influences, like some guy saying, we're not going to tax oil, right? So this is a great accessible read. This one just came out, Dan Davies. I'm only about 30% through this one, and usually I don't recommend something I haven't completed, but the sarcasm and the barbs he throws in this one are like top notch. And if anybody has ever worked in a massive company and just stood at their desk beating their head against a stack of TPS reports, this book is for you. It talks about why these systems in and of themselves both self-perpetuate and then give these bizarre results. And this one is a little bit harder to find, but there is a Kindle edition of the 3rd edition, and sometimes you can find the older editions floating around in like archives and stuff. But it's just an engineer's book about the engineer's engineer book about thinking about systems, about all those old adages about, yeah, that's not gonna work and here's why. Taking into account people, processes, all those things that we usually externalize, but ironically have much more of an effect on the capability of the software we write to do its job. Nothing can defeat Bob, who's going to make sure that he deletes every single line before he uploads the text file, including the header that says, don't delete this, right? So thank you for your attention.